Okay, so I hope alkynes are going all right for you. You've probably noticed for everything in the organic unit, there's two major skills we want you to have. One of them is we give you the name and you draw a picture. The other one is we give you a picture and you figure out the name. We've done the figuring out the name part, so now it's our turn to draw. They're giving us formulae here or names, and we have to draw what the molecule looks like. Pent-2-ine. Pent means 5 carbons. One, two, three. I'm single bonding them for now just because we have to have something holding them together or this wouldn't be a molecule. Now, on carbon number 2, we have a triple bond. Oh, I'm sorry. That was carbon number 1. Don't do that. This is carbon number 1. This is number 2. That's where the triple bond starts. So there we go. That's pent-2-ine. And if we were filling in the hydrogens, this carbon has 4 bonds. It's used 1. It's got 3 left for hydrogen. This carbon has 4 bonds, and they're all accounted for. This thing is maxed out and cannot hold any hydrogen. Neither can this one. It's got the 3 bonds on the left and 1 on the right, so it can't hold any more. This carbon has 1 bond to the right, 1 to the left, so I got my right and left backwards there, but I hope you got the idea. 2 hydrogens available. And this carbon has a single bond being used, so it's got 3 more free for hydrogen. That would be the structural formula for this. Now, if you want the line structural formula, that would have a single bond. There we go. Then it would have a triple bond. Da, da, da. And the line structure becomes you draw a triple like that. And then back to singles, we have 2 single bonds coming after this. So here's one of them. And they always look nicer in the book, but there's me doing pent-2-ine. And if you're counting carbons, there's a carbon here, second one there, third one, fourth, and fifth. So it really is a pent. Okay, for ethyl, we'll get to that in a minute. Hept-1-ine. Hept means 7. 1, 2, 3, 4, 5, 6, 7. On the very first carbon is our triple. There we go. On the fourth carbon, 1, 2, 3, 4, we have an ethyl group, which means 2 more carbons. So I'll do it that way. If we line diagram this, we have from our first carbon to our second is a triple bond. After that, we have 1, 2, 3, 4, 5 singles. So 1, 2, 3, 4, 5. And let's just check that quick. Hept means there should be 7 carbons. 1 on the end of this. 2, 3, 4, 5, 6, 7 looks good. And now on the fourth carbon, 1, 2, 3, 4, right here, we have an ethyl group. So there's 1 extra carbon, and ethyl means 2, so sorry about that. Not quite enough room, so there's the 2 carbons for our ethyl group, and here's where they attach to the primary. And good grief, 2,2,5,5,6,6 hexamethyl hept-3-ine. Okay, well, close your left eye so that this part doesn't cause you to panic prematurely and focus on what we can do. Hept-3-ine means 7 carbons. 1, 2, 3, 4, 5, 6, 7. Starting from the third carbon, we have a triple bond. So first carbon, second carbon, third carbon is where our triple occurs. There we go. Now, methyl groups, thankfully it's methyls, they're the simplest ones, a single carbon. We have 6 of them, that's what hexamethyl means. And where are they? 2 of them are on carbon number 2. 2 of them are on carbon number 5. 1, 2, 3, 4, 5. And 2 of them are on carbon number 6. Wow. Okay, can we line structure that? Yeah, probably. Our primary goes single, single, triple. So single, single, triple. Then single, single, single. So 1, 2, 3. Sorry, that triple is not wrong, but I just want to make it look a little better. They're normally drawn a lot tighter than that, so they look more like a single bond there. Okay, that's a lot better. Okay, so that takes care of our primary. Then what's attached to the primary? Off the second carbon, we have 2 methyl groups. Now, it isn't nice to have a branch going inside an angle like this because electron repulsion, but we're doing a 3-dimensional thing on 2-dimensional paper. Something's got to give. There's really nowhere else I can put this unless I have 2 sticking out that way. So I'm going to go up and down, and forgive me, I know this is not optimal, but we kind of have to when we have this many branches. Then on carbon number 5, 1, 2, 3, 4, 5, we have 2 more methyl groups, 1 up, 1 down. And on carbon number 6, right next to it, we again go 1 up, 1 down. Wow. Well, this will feel like a vacation after that one. Relatively simple. Blah, 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 known 1 yne. Focus on this first. Known we don't see very often, but it means 9. Carbon, 2, 3, 4, 5, 6, 7, 8, 9. And on the very first carbon, we have our triple, the part that makes it an alkyne. Okay, so there's known 1 yne. Now, there are 2 methyl groups, and they're both on carbon number 8. 1, 2, 3, 4, 5, 6, 7, 8 is this one, and it's got 2 methyl groups on it. There we go. And if we do a line diagram for this, it goes triple first. Then 1, 2, 3, 4, 5, 6, 7 singles. 1, 2, 3, 4, 5, 6, 7. And off the second last carbon right here, we have a methyl group, and then we have another one.